Hello and welcome to section 8.1, using basic integration formulas. This section is going to act as a review for a lot of the integration we've done up until now. You'll probably notice some things from Calc 1 as well. Okay, so we start off with a table of some basic integration formulas. You guys have probably seen a lot of these in Calc 1. Okay, these are some of the more common ones that we've dealt with. You see the constant, the integral for ln of x, the trig integrals. We have the new hyperbolic trig integrals, the inverse of the hyperbolic, the inverse of the trig functions. So we have all these common integrals. Okay. So this section should be more or less like a review of some common integration techniques. Okay, so let's take a look at the first one. Evaluate the integral. Okay, we have from 3 to 5, and we have the integral. We notice we could do a little u substitution here. If we said u is equal to x squared minus 3x plus 1, and then du would equal 2x minus 3 dx. Okay, so luckily for us, we have that 2x minus 3 dx. So this could be solved with a u substitution form. Okay, so in order to continue with the u, I'm going to change my limits of integration. I will say that when x equals 3, I'll try to figure out what the u is. So when x equals 3, I could plug 3 into my equation up here for u. U will equal 3 squared minus 3 times 3 plus 1. So that gives me 9 minus 9 plus 1. So 9 minus 9 is 0, plus 1 is 1. So when x equals 3, u equals 1. Okay, and then when x equals 5, what does u equal? So u would equal 5 squared minus 3 times 5 plus 1. Well, 5 squared is 25 minus 15, that's 10, plus 1 is 11. So u would equal 11. Okay, so now we have our new limits of integration based on u. Okay, so we have our integral. We have from 1 to 11, and we have square root of u, and then we have du. Okay, so we could work with this. We could say that this is going to be u to the negative 1/2 du, and then we can integrate from here. And so if we add 1 to the negative 1/2, we get a positive 1/2. So this would be u to the 1/2 divided by 1/2. Okay, in other words, when we divide by 1/2, we get multiplied by 2. So 2 u to the 1/2, which is the same as 2 times the square root of u. Okay, so let's plug that in. That means this will be 2 square root 11 minus 2 square root 1, which is 2 square root 11 minus 2. Okay, if you want to leave it like that, you can. If you want to pull out the 2 and say this is square root of 11 minus 1, you can. If you want to evaluate it, use a calculator on the side, you could get approximately 4.63. Okay, so either one of these is fine. Okay, let's take a look at our next one. It says complete the square to evaluate. Okay, so let's take a look at how we would complete the square in our example 2. We notice that if we have the denominator, it's 8x minus x squared. Let me work with that first. I have 8x minus x squared. I could say that if I'm going to rewrite this, this would be negative x squared plus 8x. Okay, now when I like to complete the square, my coefficient on the x squared is usually positive. Okay, so what I'm going to do first is I'm going to pull out this negative 1. So I have my x squared, I have the positive coefficient in there, minus 8x. So now when we complete the square, remember the one thing we do is, in order to complete the square, we have, I'm going to write the negative 1. We take, I like to say we take half of the x squared. We're really taking the square root of the x squared, which is x. So we take half of x squared. We take half of the negative 8, which is negative 4. We close the parenthesis. We square it. Now what happens when we do that? This negative 4, we square it. Right? So negative 4 squared is a positive 16. Now, because we're completing the square inside the expression, because we added 16, we also have to take away 16. Okay, so we have this scenario. So now, if you think about it, this portion becomes this. Right, so that x squared minus 8x plus 16, that becomes the x minus 4 quantity squared. Okay, and then this minus 16 we're going to keep outside. But now think about it, you have a negative 1 here that would distribute to that negative 16. So as you think about that, you have to acknowledge that and make the sign of that negative 16 becomes actually a positive 16, because negative 1 times negative 16 would be a positive 16. Okay, so that would be our expression when we complete the square. Now another way you could rewrite this is you could put the 16 in front and say 16 minus x minus 4 quantities squared. Okay, so let's see what happens when we do that. We have integral dx over square root of 16 minus x minus 4 quantities squared. And so if we look at this, this is going to kind of fall into line with our inverse sine formula for integral. Okay, so if we remember inverse sine, we have du over square root of a squared minus u squared. Okay, so that means for us, the u would be x minus 4, and that makes du would equal dx, And then a would just be the square root of 16, which is 4. Okay, so this is going to be, this will be the arc sine of u over a plus the constant. Okay, so if we work with that for our problem, that means we will have arc sine or inverse sine of u over a, so x minus 4 over 4 plus c. And that will be the final answer. Okay, let's take a look at our next one. Evaluate the integral. Okay, so with this one, this might bring you back to your pre-calc days when you're learning about trig identities. We had a sine addition formula. So if you have the sine of two angles that you're adding together, you saw a formula that happens something like this, right? So the formula for that would be the sine of, and if you look at the two angles, it would be x plus 2x. Okay, now we could easily combine like terms there and we get sine of 3x. Okay, so just by recognizing the formula, you can go from that step to this step. Okay, so just okay, so now from here we can integrate the sine. When we integrate the sine, we get negative cosine, but because of the chain rule, we're expecting a 3 here. We don't have a 3. Okay, so we have a negative cosine. We don't have a 3, so to offset that, we have a negative 1/3. So this would be negative 1/3 cosine of 3x plus c. Okay, let's take a look at our next example. Okay, we have a definite integral. Let's take a look at this one. A common technique we can do here is we can multiply by the conjugate. Right, we have a 1 minus sine x. We could make this, the conjugate would be 1 plus sine x. So right here at this step, we would multiply top and bottom by 1 plus sine x. Okay, so next we have integral of 1 plus sine x over, and if we FOIL this out, we get 1 minus sine squared x. Okay, and then we could rewrite the 1 minus sine squared x. 1 minus sine squared x is cosine squared x. Okay, so that means we could now split our fraction. We could say 1 over cosine squared x plus sine x over cosine squared x. Okay, so that means if we have 1 over cosine squared, that's the same as secant squared, right? 1 over cosine is secant. So this will be secant squared x. And then for the sine over the cosine squared, you could do a little intermediate step here and say this is sine x over cosine x times 1 over cosine x. So this gives you tangent times secant, right? So we have tangent x secant x. Okay, so that means we could integrate this. Okay, so when we integrate secant squared, that's just the tangent. We have tangent of x. And when we integrate tangent secant, that's just the secant of x. Okay, so that means we can plug in our limits of integration. So that means we have tangent of pi over 4 plus secant of pi over 4 minus tangent of 0 plus secant of 0. Okay, so tangent of pi over 4 is 45 degrees. Tangent of 45 is 1. Secant 45 degrees, that would just be radical 2. And then we have tangent of 0 would be 0. And secant of 0, that's 1 over cosine of 0. Cosine of 0 is 1. Okay, and we see that we got a 1, and then when we distribute the negative here, that would make that a negative 1. So these two would cancel. And so we're just left with square root 2. All right. Let's take a look at our next one. Evaluate, we got the integral. Okay, whenever you have an improper fraction, like if you have a top degree is greater than the bottom degree, we could just do long division on this. And then we could try to integrate the quotient with the remainder off of that long division. Okay, so let's do a long division on this. I'll do that over here. We got it's being divided by 3x plus 2. And inside the dividend, we got 3x squared minus 7x. And then this will be 0. Okay, so 3x squared goes into 3x how many times? So you can just divide the leading terms. 3x squared divided by 3x. 3's cancel. X squared divided by x would be just x. Okay, so we have x. So now multiply x times 3x plus 2. X times 3x, 3x squared, x times 2, 2x. Subtract. So we have 3x squared minus 3x squared, that's gone. Negative 7x minus 2. Negative 7 minus 2 would be negative 9. Negative 9x. Okay, we have, normally we bring down this, there's nothing to bring down. If you want to put in like a token 0, you can. Okay, and now how many times would 3x go into negative 9x? Well, x's would cancel. Negative 9 divided by 3 would be negative 3. So we put negative 3 here, and now multiply. Negative 3 times 3x plus 2. Negative 3 times 3x would be negative 9x. Negative 3 times 2 would be negative 6. Okay, subtract. Negative 9x minus negative 9x, that's gone. 0 minus negative 6 is a positive 6. Okay, and if you guys remember, the way we write the remainder is we put that remainder as a fraction on top, and then the 3x plus 2 would be the denominator. Okay, so now this integral would become this quotient plus the remainder. So x minus 3 plus 6 over 3x plus 2. This would be dx. Okay, so we could easily integrate that. So when we integrate it, we can integrate the x. What do we get? That would be x squared, 1/2 x squared minus 3x. And then for our fraction here, this looks like a ln. If we do ln of 3x plus 2, then we would have to multiply by 3. But here we have multiply by 6. So that's good. We could just do 2 times, right? We could do 2 times. So we would have to say plus 2 ln of 3x plus 2 plus c. I'll do it like this, plus c. Okay. Pretty straightforward. Let's take a look at our next example. So with this one, we see that we have, we could do a little separation of the top. We could say that this is going to be integral of 3x over square root of 1 minus x squared plus 2 over the square root of 1 minus x squared. Okay, so we could do something like that. Okay, so as we do this, for this first one, for the first part, let's say we could pull out the 3. Okay, in fact, I'm just going to split the integral. I'll make it 2 integrals like this. And then this one will be 2 times the integral of 1 over square root 1 minus x squared. Okay, so let's take a look at the one on the left. We could do a little u substitution on the left. Right, like if I said u was equal to 1 minus x squared, then my du would be negative 2x. Right? So now I don't have that negative 2 there. So if I just solve for x, I would divide by -2. So divided by -2, that's the same as saying -1/2 du equals x dx. Okay, so that means for what I have 3, and then I have u. I'm going to make this -1/2, right? Because I have the square root on the bottom. So -1/2. And then I will have to multiply by -1/2 du. Okay, so I could pull the -1/2 out. So I have -3/2 integral u to -1/2 du. Okay, so I could integrate that. That means if I add 1, that becomes u to the 1/2. Then I divide by 1/2, which is the same as multiplying by 2. So I have -3/2 multiplied by 2, u to the 1/2. And the 2's here would cancel. So I have -3, and I can substitute back in for my u, which is 1 minus x squared. So it would be 1 minus x squared. Now let's see what's going on the right side with this part. Okay, now this is a slightly different form. I should say, not slightly, it's a totally different form. We don't have the du in the problem. Like we're expecting some kind of x, right? Normally we're expecting 2x, but we live with just having an x there. That's fine as well, but we don't have that. So now this takes on a different form. Okay, and if you remember early in the lecture, we had one that looks just like this. This is an arc sine, right? So this is an arc sine of just x. Okay, so that one really became very easy, and it would just be with a 2 in front. That's the only thing. So this ends up becoming 2 inverse sine of x. Okay, so let me now combine that one with what I have here. So I have -3 square root 1 minus x squared plus 2 inverse sine of x, and then plus c. Okay, so that would be the final answer for the whole thing. Okay, so it's important to know how you could split apart the integral, and then you're basically doing 2 integrals, and then you're combining the answers at the end. Okay, let's take a look at this one. Example 7. Integrating. So here, with this one, we could try a little substitution. So we have, we could do substitution with this, maybe say u would equal 1 plus the square root of x. Okay, if that's the case, then du would be, well, derivative of 1 is 0. Derivative of x to the 1/2, right? Because this is like x to the 1/2. That becomes 1/2 x to -1/2 dx. So what does that mean? That means du becomes 1, and then x to the -1/2 will go to the bottom. The 2 would stay at the bottom. So that's what du would be. Okay. So now we don't have that. Right? So we're going to have to do a little fancy substitution here. Let's see, we have dx. If I solve this for dx, that means I can multiply both sides by 2 radical x. So I have 2 radical x du equals dx. Now I want to get rid of this radical x. So here's where my fancy substitution comes in. So this u, right? U equals 1 plus radical x. Well, now if I take away the 1 and take away 1, I get this solved for radical x equals u minus 1. So I could plug in u minus 1 in place of that radical x. Okay, so I have 2 u minus 1 du equals dx. Okay, so let's see how this is going to look. So we have integral we have integral 2 u minus 1 du e over, and then the denominator would be, we just made that become u, so that would be u cubed. Okay, so our numerator, if we distribute the 2 out, our numerator becomes 2u minus 2 over u cubed. Okay, so if we split this into 2 fractions, we have 2u over u cubed minus 2 over u cubed. Okay, which simplifies slightly. The 2 u's here would cancel, so we have 2 over u squared minus 2 over u cubed du. Okay, so when we go to integrate it, very easy to integrate. You have here 2u to negative 2 minus 2u to negative 3 du. So that means when you add a power, you get u to negative 1 divided by negative 1. So this becomes negative 2u to negative 1. And then here, negative 3 becomes negative 2 divided by negative 2. So this negative 2 divided by negative 2, that's why I put a plus. And we get u to negative 2. Okay, so let's just take a look real quick. This becomes negative 2 over u plus 1 over u squared. Okay, we could easily put this over one denominator. If I get a common denominator here, this will be negative 2 u over u squared plus 1 over u squared. Okay, now remember what the u was. u was equal to 1 plus the square root of x. So I have negative 2, 1 plus the square root of x plus 1 over 1 plus the square root of x squared plus c. Okay, so that's a little bit, if you want to combine with the same denominator, it would have been, it's also perfectly fine if you came here at this step and just substituted in for u as well. So you'd have negative 2 over 1 plus the square root of x plus 1 over 1 plus square root of x squared plus c. So either one of these is fine. Okay. Let's take a look at, this is our last one. Evaluate negative pi over 2 to pi over 2 of x cubed times cosine of x dx. Okay. Well, one thing we notice here is there's no easy way to go about doing this. But one thing we have to pay attention to is that we have x cubed, which is an odd function, and it's being multiplied by cosine x, and cosine x is an even function. So if you have an odd function times an even function, your end result is an odd function. Okay. Now, if you remember the properties of integrals, if you go, if the bounds are the same, but one is the negative bound, the other one is the positive bound, these are going to always cancel each other. Like when you have an odd function, these are always going to cancel each other, and you'll end up with a 0 net result here. Okay, so therefore, when you go to evaluate this, and this is true for any time if you have an odd function and then you have the two bounds are equal distance from your origin. You go on the same distance to the left as you're going to the right. The two areas will cancel each other and you'll get 0. Okay. So that's it for this lesson. Any questions, just write me an email. Have a good day. Have a good night. We'll see you soon.